You are going to need a highlighter, so please go ahead and get that out. And I do have papers that I am going to be passing out to you guys before the end of the day that I can read. Thank you. You guys can have to get wherever it pulls up. You can move it over in front of the TV. I don't care. Yeah, you can drag one of those over there if you want. Alright. So today we are going to be discussing how to determine if something is linear or non-linear. You can move that wherever you need to. Alright, so a function that is linear will have a constant rate of change and can be distinguished from non-linear functions in each of the following representations. The biggest thing is the constant rate of change. That has to do with your table. Priya, will you turn on the light, please? Alright, so there are a couple different ways that you can determine if something is linear or non-linear. The first one is looking at the equation. And we are moving into y equals mx plus b, so that is essentially where we're going with all of this. So a linear equation can be written with y equals mx plus b, so it's in that format. And that format being that the x is to the first power. Okay, it's not squared, it's not cubed, it's nothing, it's to the first power. Why is this so gross today? So if you're looking at the example that they gave, they have the y equals, your m is 2, your x is to the what? Is it to the first power, second power, third power, what power? First power, because there's no what? Not a variable. There's no what connected to this x. What does it mean to have a power? Yes, it's an exponent. So, does the x have an exponent? No, it doesn't. I mean, technically it's got a 1, but if it doesn't have, or if it has an exponent that is 2, 3, and so on, then you know that that's not going to be linear. And then obviously you can have addition or subtraction back here. So that's one way, looking at linear equations. The next one is the table. So a constant rate of change. This means that it increases the same or it decreases the same from like box to box to box to box. Make sure that I give you the right words. So your x value will change the same and your y value will change the same. All right, so looking at this table, looking at just your x's, you have 0, 3, 6, 9. How is that changing? It's increasing by 3 every time, right? So from here to here, you do plus 3. From here to here, you do plus 3. From here to here, you do plus 3. Everybody see that? Everybody agree with that? Okay. Now, the bottom, the y's, we have 2, 4, 6, 8. What do you guys notice about that? It's plus 2. So it's a constant rate of plus 2. So it is increasing the same on the bottom for every number, and it's increasing the same on the top for every number. It can also decrease the same. All right, so it doesn't just have to be plus. It can be plus or it can be minus. And then the last one to determine if it is a linear function is if it is a straight line. So your graph has to be a straight line. And this is one, like this was a big thing that we missed on the check-in. Like it's one of the lowest ones, is determining if you're given ordered pair and you have to figure out if it is a I just had a complete brain fart. If it is a linear function or not. So this is one that we really struggle with. All right, we're gonna look at number 1 and number 2. And we're gonna determine using the equation, using the table, and using the graph, if these are linear or non-linear. All right, so looking at number 1. Our equation is y equals half x. So just by looking at the equation, we're going to do a stand-up, sit-down thing. So stand up if you think that this is, by looking at the equation. So look at the examples we just did up here. And then look at our equation. Okay? So stand up if you think yes. All right, have a seat. Stand up if you think no. Stand up if you're not sure. That's okay, because we're not sure. We're just learning. So it's okay if you're not sure. All right, so looking at the equation, we're a little unsure. So now let's look at our graph. So just looking at our x numbers, what do you notice about -4, -2, 0, 2, and 4? What do you notice about those? They're what? Yes, they are increasing by 2, so each one of those is a plus 2. So from here to here, this is plus 2. From here to here, this is plus 2. From here to here, plus 2. And from here to here, plus 2. So knowing that, we're going to do the stand-up, sit-down thing again. Do we think this is a function? Stand up if you said yes. Okay, so we have pretty much everybody. Why? Why are you guys now a little bit more convinced that this is possibly a function? What do you guys think? All right, Nevaeh, what do you think? Right, because it's a constant rate of change. Obviously, we have to figure out our y values. And the way that we would figure out our y values is what? What would we have to do with our equation? Huh? We have to plug in our x's. So half of -4 is what? -2. Half of -2 is -1. Half of 0 is 0. Half of 2 is, and half of 4 is 2. So we're also doing what with each one of these? Raise your hand. What did you say, Richard? What? Well, we're going to graph them, but what did we do to each box? Like, was it the same? Like, did we increase or decrease by the same number? What we do, Sarai? So how do I go from -2 to -1? What do I do? Add or subtract? Add what? +1. So each one of these is a +1. Okay? So yes, this is a linear equation. Technically, we don't have to graph, but yes, we're going to, because Lord knows we need to practice our graphing. Okay? So yes, this is a linear equation. Now, I'm going to graph. I'm going to go 4 to the left, -2 down. That's my first dot, or my first point. All right, raise your hand and tell me the next set of points. Nevaeh. 1 down. Okay, so 2 to the left, 1 down. All right, what's my next point? What is my next point, Ben? Guys, you need to be following along. Huh? Yes, it's going to be on 0, but follow along. All right, the next one. Jeffrey. I'm sorry, I didn't hear you. 2 to the right, 1 up. And then the last one, we're going 4 to the right and 2 up. So when you connect these, they should be a what? A straight line. So we have many reasons, and we've proved time and time again that this is a linear function. You can talk about the graph, you can talk about the table, or you can talk about the equation. So we're just going to use one that's really simple. We're going to say yes because the table has a constant constant rate of change with the X and Y values. What would be another reason, though, that this would also be a yes? So we use the table, but what's another thing that we used? Okay. The graph made a straight line. Okay, so if nothing else, guys, look at your table. If you don't have a table, plug in your numbers for your equation. See what you get for X and for Y. All right, I'm gonna have you guys do number 2 with your group members. Okay, so you're trying to determine if this is a function. You're gonna write yes or no. And your equation is y equals x squared plus 1. All right, so go ahead. If you don't have a friend to work with, you may move to get a friend to work with. Okay, so Cam, you can move real quick. You just take a quick word. I'll text this on. Quickly, I'm gonna give you guys 2 minutes. So you're working together to figure this out. your equation? Can you tell me yes or no? What's your equation? Like, what's the format of it? Right, so this is your format, right? Y equals mx plus b. So the first power only. So looking at your equation, y equals x squared plus b. So do you know if it's linear or non-linear just by your equation? That's what I'm asking you. Do you know? Okay. So then I want you to plug it in. So then you're going to do 32 this and go to west side. Or west side. The side of there. Alright, next one you have negative 1. So negative 1 plus 1. Okay. So then what's 0 plus 1? And then the last one, or last two, 1 times 1. Plus 1. Right. And then 2 times 2. Plus 1. Round it up. Or look at this and see, does this increase? Does it increase the same every time? So from 5 to 2, what do you do? Or do you want to so you're going to have 3, right? But then from 2 to 1, what do you do? How do you go from 2 to 1? What, 5? I'm out. If I have 2, I have 1. So from here to here, you said minus 3. How do I go from 2 to 1? 5. Huh? 1. Alright, so what did you have about these here? Is it the same? So you say no because it's different types. Obviously, that's what you graph it, but that's how you.
Like I've seen.
We're going to talk about this. Alright, so stand up if you said yes. Stand up if you said yes. Alright, let me rephrase that. Stand up if you originally said yes. You originally said yes. It's alright, there's a few other people that are just not going to stand up. Alright, so stand up if you originally said no. Okay. Alright, so have a seat. What is the format of our equation? So again, you have to look up here and say, okay, y equals mx plus b. Your x is to the first power only. So that means that there's no square, cube, nothing next to your x. So looking at our equation here, what do we see right away? What do we see right here? X squared. So this is x squared, which means there's no way that this is a linear equation or a linear function. All right, but if we don't remember that rule, we can go ahead and we can plug in our numbers and we end up with 5, 2, 1, 2, 5, right? And then we say to ourselves, okay, well, how do I go from 5 to 2? Yes, there's a fly in the room. If you cannot focus on what we're talking about because there's a fly in the room, I'll shut all the fans off and the doors and we will all die of heat stroke. So please concentrate. All right, Cam, how do you go from 5 to 3 or 5 to 2? Cam, we went through this together.
Put it on my finger, so check.
All right, just making sure we're on the same page. Now, Cam, how do we go from 2 to 1? Minus 1. What do you notice there? The rate of change is not the same. So therefore, you know this is not a linear function. But let's say, okay, you still think, well, it's a pattern, Miss Kinney. It goes 5, 2, 1, 2, 5. It's got to work. So we're going to graph it. So I'm going to go 5 to the right, 2 up. Sorry, I can't read. Don't. It's okay. 2 to the left, because it's negative 2, 5, and I'm gonna go 5 up. Then it's negative 1, 2 up. Then we have 0, 1. Then I have 1, 2, and then I have 2, 5. And what do you notice about your graph? Right. So it is not a straight line. So you need to write no. And pick any reason that we just proved. Because the equation is to the second power, because it's not a constant rate of change for whatever, or because our graph is not straight. I don't care what you pick, but you need to write something. Stand up when you're done. All right, again, any one of those. When you're done, stand up. All right, slide over to number 3. So it says use each of the given functions to create a table or graph. Then explain if the function is linear or not. What? No. All right. What do you notice about the equation? Looking at the equation, what do you notice right away? Right. The power is completely wrong. So it's to the power of what? 3? So x is to the 3rd power. So we know what? It's not linear. Because this thing is super aggravating. We know it is not linear because it's to the 3rd power. So technically, we would be done. We're not going to be done. Because why? Because what? Because you have to practice. All right. So now we're going to plug in. So negative 2 times negative 2 times negative 2 is what? Don't tell me it's negative 6. Don't, because it's not. Negative 2 times negative 2 times negative 2. Jeffrey? Huh? Are you sure? It is 8. But I don't know if it's positive. Negative times a negative gives you? Times a negative gives you? Negative.
What? Oh.
You have 3 negatives. All right, the next one, negative 1 times negative 1 times negative 1. That gives me what? Raise your hand. Negative 1. 0 times 0 times 0. Raise your hand. Ben?
0.
You sure?
Yeah.
Okay. 1.
Negative 0.
1 times 1 times 1 gives you, raise your hand. Right in. 1. And then 2 times 2 times 2 gives you what? 8. All right, so looking at our graph, we should be able to say, okay, no, this is not linear because why? Constant rate of change is not. And then we're going to graph. So 2 to the right, you're going 4 up because it's increasing by 2. One like halfway in between, and right there. Then you have 0, 0. Then you have 1, 1, and then 2 there. So this is your line. Oh, I totally did that wrong. Disregard mine. No, I didn't. One. Did I?
Yeah, negative.
Okay. It should look like this. Should look like that, right? Yeah. Should look like this. I graphed it wrong. Don't yell at me. I got all the answers. I'm just not looking at them. See what happens when I don't look at them? All right. So it should go here, there, 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 there. So is that a straight line? No. All right. So again, pick whichever one. I graphed it wrong, Cam.
How did you get
Because I do my homework. All right, so you're picking either the graph, the equation, or the table, and you're telling me why this is not linear. I don't care. Right. Brielle, if you're going to continue to talk, baby, you need to move. I am up here teaching. That's where you need to be. Stand up when you have your explanation. All right, slide to number 4. You are doing number 4 with your table mates. Stand up when you are finished. Ellie, where did you take Kira's book bag? On the right side or left side? The what? Okay, it's on the right side though? Okay. Yes. Yeah. this one. So your equation is y equals 1.5 x plus 2. Raise your hand if you think that this is yes, just based off of the equation. Raise your hand if you think yes. If it follows the format of y equals mx plus b. Okay? Is it to raise to a different power? Is that x to any other power than 1? No. So technically, this is an linear function. All right. Then, when I plug my numbers in, Cam, don't judge me. I can't do math today. Okay? Don't judge me. All right. So, -4 times 1.5 plus 2 gives me what? Huh? -4. Told you I can't do math today, Cam. -2 times 1.5 plus 2 gives me what? Someone other than Nevaeh.
-1.
Someone other than Richard. All right. 1.5 times 0 plus 2 gives me what? It's 2. All right. 2 times 1.5 plus 2. We forgot to add the 2, Cam. That's my bad. It's all on me, not on you. Ariana. 5. And 4 times 1.5 plus 2 gives you what? Brielle. 8. When you graph this, you go 4 to the left, 4 down. You go 2 to the left, kind of in the middle because it increases by 2s. Then you go 0, 2. Then you go 2 to the right, halfway up. And then 4 to the right, there. What do you notice about your line? It's a straight line. So, again, pick something that tells you so you can use the equation. Or you can use your graph, or you can use your table. Pick one reason as to why it is a linear equation. Alright, the last one. Number 5. Y equals 12 divided by x. Stand up if you think this is a linear function. Stand up if you do not think this is a linear function. You are correct. If you are standing, this is not. Why? Why is this not a linear function? Well, just starting with the equation. You don't know? Does it follow the format of y equals mx plus b? No. All right, so she said it doesn't have a power, and she is correct. There is no power. So technically we could be confused with this. We could say, well, this doesn't have a power, so therefore it's right. But this is wrong. This is not a linear function, because why? Someone other than Nevaeh and Ben. Why looking at this equation? Why looking at y equals 12 divided by x do we know that this is not a linear function? The lack of care in this classroom today is outrageous, y'all. Like, you just bombed a check-in, and we're trying to move forward, and there's no participation except for 4.5 people. Callie. How? Because she pointed out, well, the x doesn't have a power, so technically doesn't it? They're connected, what do you mean? Huh? It's a negative? You gotta speak up, baby. I can't hear anything you're saying. Callie, use your outside voice. Do you have one of those? All right. What does that mean? They're together at the top. It's separated by what? All right, so it's separated by division. And we know based off of the y equals mx plus b, it's not division, right? It's what? Multiplication. When we fill out, yes? Yes. When we fill this out, because we're just going to quickly go through this, you're going to get 12, 6, thank you, 4, 3, 2. So what do you notice about the table? What do you notice about the table? Brayden. Is there a pattern at all? A constant rate of change? No, it's all over the place. And then when you graph this, it's 1, 12, 2, 6, 3, 4, 4, 3, and then 6, 2. So this line looks like that. So there are a ton of things that are wrong with this. All right, again, pick one. So no, because why? Huh? No, I'm asking you to write it. So just write no and then give me one of the reasons why. Stand up when you're done. You didn't know that?
No.
Oh my Lord. All right, well, good to know. All right, we're not gonna do number 6 because I don't want to confuse you guys right now. What we are gonna do though, is we're gonna do number 7, and we're gonna label it linear or non, based off of the equation only. So you have y equals 4x squared. Stand up if you said yes. Okay, so then we all say no? Raise your hand and tell me why. So this is non, tell me why. Jasmine? Right. Because it's got this little square root right there. All right, the next one, y equals negative x minus 1. Stand up if you said yes. Why, Anthony? Huh? Yeah, it matches the y equals mx plus b because technically the negative x is a negative what? It's negative 1x, right? So it follows that pattern. And then the last one, y equals 10 divided by x. Stand up if you said yes. All right, so then this is non. Raise your hand and tell me why. Audrey? So that's division, and we said to the second power. All right, go ahead, blue send. Yeah, but I mean, it's still, it makes sense though, right? Yeah. Start. All right, so you need to slide over to the right side in your notebook. And you need to title it linear versus nonlinear homework. Yes, you have homework. However, if you use your time wisely, you won't have homework. So, this should be fairly easy. This is not rocket science, y'all. You're simply going to label whether it's linear or nonlinear, and you're looking at the three up here. You're looking at these graphs, and then you're looking at the tables. The hardest part will probably be 9 and 10. You should finish 1 through 8 in about 3 minutes. Okay? When you are done, you are working on anything that you owe me still. If you're good with everything, work on your delta math.